Welcome back to our video on finding the distance between 2 points. If you haven't noticed, we're right at the beginning of geometry, and finding the distance and copying distances and things like that have shown up quite a bit. So how do we actually find the distance between 2 points? If I want to find the distance between P and Q, how do I find that? Well, it's not too complicated, but it does involve using a little bit of math that you learned back in 6th grade and you've been using ever since. So take a look at the point P, the point Q. We want to find the distance between them. Now, in order to do that, rather than trying to measure it or anything with an inaccurate measurement, we want to get it exactly. So instead, we're going to go horizontally and vertically. We're going to find out each of those distances. And once we do, we're going to simply use the Pythagorean theorem. Now, the distance from here to here is actually pretty easy to get. Whenever we're on coordinates, that's actually our x-coordinates, specifically the difference between them. So this is x1 or x2 minus x1. And that's from Q minus the P, because Q is the one that's on top. We could subtract the other way and it would still turn out to be a similar answer, but we want to make sure we're kind of doing it right. All right, and then we have our y values that go up and down. So we want to subtract our y values here. This is y2 minus y1. Okay, so we're going to take our x values, subtract them, take our y values, subtract them. And what that'll do is get us those two lengths. And then once we've got those two lengths, we're going to use the Pythagorean theorem to do it. Altogether, really, this is just looking at that Pythagorean theorem. We would do x2 minus x1, but with the Pythagorean theorem, you do a squared plus b squared. You have to actually square the lengths of this side. So we've got to square this. x2 plus x1 squared. And then we got to do the same to the y's. y2 minus y1, and we're going to square that. That's the a squared plus b squared part of our Pythagorean theorem. And this equals d squared. All right, so a squared plus b squared equals d squared, but we don't want d squared. We just want the distance, not the distance squared. So there's one step we can do to undo a square. If I want to undo a square, I'm going to use a square root. So I have to apply that to both sides to undo that square. So it'll cancel out, and I end up with this result. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. There we go. That is our distance formula. Take a moment to look at it, make sure you kind of understand the ideas here, that it's really just the Pythagorean theorem, and then make a copy of it and put it right over there. All right. So, Travain claims that you can use the formula, but with a slight change in order to find the distance between 2 points. Notice that there's one small change in here. Instead of x2 minus x1, it's x1 minus x2. Instead of y2 minus y1, it's y1 minus y2. Can you find the distance between 2 points if you put it on backwards? And the answer here is, let's check it out. So if I do x1 minus x2, let's just think about this for a few pairs of numbers. Let's say we have our first set of coordinates. That is 3, 7. And our second set of coordinates is 4, negative 9. Okay? So let's go ahead and find out what x1 minus x2 is and x2 minus x1 is. If I do x1 minus x2, this is x1, this is x2, okay? Then I would do x2 minus x1 is equal to 4 minus 3. Okay, that's 1. What about x1 minus x2? x1 minus x2, that's going to equal 3 minus 4. But wait, that's negative 1. That's not 1. That's a little difficult. They won't produce the same result. So is the problem ruined? Can we not do it backwards? And the answer is no, we can still do it backwards. Notice the ones here. This is a positive 1. If I square 1, I'm going to get 1. What if I square negative 1? Well, that becomes negative 1 times negative 1. Negative 1 times negative 1 is positive 1. So if I square either one of them, then it becomes positive 1. So with the x, it works. What if we use the y's? This y1 and this is y2. So y2 minus y1 is equal to negative 9 minus 7. y1 minus y2 is equal to 7 minus negative 9. And let's go ahead and find out what those become. y2 minus 1, y1, negative 9 minus 7 becomes negative 16. If I do 7 minus a negative 9, that becomes 7 plus 9, which gets us to positive 16. And notice how they become the same number, but with a positive or negative value, the same natural number there. So if we square both of them just like we did, square, it becomes 16. No matter what, we're going to get the same result. This is just one example, but it works with everything. And so what Travin's claim is still works. What matters far more than making sure that you've got x2 minus x1 is making sure that they have the same pattern. If this is your x1 coordinate, this needs to be your y1 coordinate. You can't switch these, but not switch those. If you do that, it's not going to end up in a problem here, but it'll end up in a problem a lot later. So please make sure you're keeping aware of that. All right. With that said, you've got a problem over here that you want to try on your own. A pitcher throws a ball to a batter. The batter hits the shortstop. Now I'm going to do one of them real quick because it's asking you for what's the total distance that the ball travels. And so I want to know, okay, the ball travels in a straight line between each. A pitcher throws it to the batter, and the batter hits the ball to shortstop. So the pitcher goes to the batter goes to shortstop. So we need to find out the total distance that ball went, and we'll find out both of those, and we're going to compare it to the batter getting to the first base, just to see if the batter can get to first base faster than the ball can. Now, looking at that pitcher to the batter, I could go ahead and draw this just like this, draw that connecting line, go across and go up. And look at that, I got a nice little value there. I can go ahead and count out my distances. Oh yeah, that's 5. Oh yeah, 1, 2, 3, 4, 5. That's 5 as well. So I got two distances of 5. And so I can go ahead and find the distance using the distance formula. Square root of, and I can just use the Pythagorean theorem, 5 plus 5 squared plus 5 squared is equal to the square root of 25 plus 25, which is equal to the square root of 50. Oh, square root of 50 is my distance. All right, I'm going to put that right there, square root of 50. Now I can plug that into a calculator and get an approximate decimal value. I believe it's going to be roughly 7 something, or 8. I think about 7. But that's the distance there. I want you to take a moment to find the distance between the batter and the shortstop. Okay, so what's the distance from here to here? And that did not color very well, so let me switch colors, put it in the red. The ball goes from the batter to the shortstop. What's the distance there? Now, you can use the system that I just did, or you could just look at the coordinates. And the coordinates here are 5, 10. And the coordinates of the batter are 0, 0. So you could just use the coordinates and the distance formula. Or you could go ahead and draw the figure and make the Pythagorean theorem like I did. go ahead and try to find the distance between the batter and the shortstop. All right, with that said, that'll bring this video to a close. It was great teaching you this.